Okay, so let's have a look at the Leaving Certificate Higher Level Maths Paper 2 for 2015, and we're going to have a look at this question here, which is question 3. So question 3 is a coordinate geometry of the line type question, and we have 2 points here, A which is 4 minus 1 and B which is 7t, so we don't know the y coordinate here. We have a line L1, 3x minus 4y minus 12 equal to 0, and this is perpendicular to AB. So we have let's say A here and B here. So let's say this is A, this is B, and we have a line going through A and B, and we have this other line here which is perpendicular to AB. So we have another line maybe going up like this, and this is L1 here, and it's perpendicular. So we've got to find the value of t. So we have A here which is 4 minus 1, and we have B here which is 7t. So you got to find this value of t here. So because we're talking about two perpendicular lines, what we could do here is maybe look at slopes. We can find the slope of AB in terms of t anyway. We can easily find the slope of L because we have its equation. And you know, when you multiply two slopes of lines that are perpendicular, you will get minus 1. So we can form an equation with t in it and solve for t. So that's the strategy anyway. So let's have a look at the slope of AB first of all, of the line AB. So our slope is going to be y2 minus y1 over x2 minus x1. And let's say well, let's say, I don't know, x1, y1 is here, and x2, y2 is here. And let's work from that. So we want y2, which is minus 1, and we want to subtract y1, which is t. And then underneath we have x2, which is 4, and we want to subtract 7, which is x1. So when you do that, you get minus 1 minus t over minus 3. And let's just tidy that up a little bit. We'll just multiply top and the bottom by minus 1. So that'll give me t minus, or t plus 1, or 1 plus t plus 1 we'll say, over 3. Okay, so that's my slope of AB. So let's have a look at the slope of this line here, slope of L1. So the slope of L1 is just going to be minus A over B. So in other words, this 3 is A, this is B, the minus 4, and the C is minus 12. In other words, the equation of L1 is written in the form AX plus BY plus C equal to 0. And the slope of any line in that format is just simply minus A over B. So in our case, A is 3, so it's going to be minus 3 over, and our B is minus 4 over minus 4. So that's just going to be minus divided by minus, which is plus 3 over 4 then. So we have the slope of L1, we have the slope of AB. We know that they're perpendicular, so we've got to find the value of t. So we know that if we multiply the two slopes, we should get minus 1. So let's do that then. Okay, so we'll just move this out of the way first. Okay, so we have 3 over 4 multiplied by t plus 1 over 3, and we should get minus 1. Well, let's see, that will give me, if I multiply the top by the top here, that will give me 3t plus 3 over, multiply the two denominators, you get 12. That's equal to minus 1. So let me just come over here now. So that's what we'll do here is just cross multiply. Here we got a fraction equal to a fraction. So we multiply the top by the bottom. So 3t plus 3 multiplied by 1 is just 3t plus 3. We got to multiply the 12 by the minus 1. So that's minus 12. That'll give me 3t is equal to minus 15. So that just gives me t is equal to, divide by 3, That'll give me t is equal to minus 5. Okay, so that's it for part 1. Let's have a look at part 2 here, or part B. So we've got to find in terms of k the distance between the point 10k and L1. So we have L1, looks like maybe looks like this, for example. This is L1. We have a point here which is 10k, and we've got to find the distance between that point and the line L1. So it's the perpendicular distance. We've got to find that distance there. Well, we have a formula for that, and that's going to be d is equal to the modulus of, just write it down first and then explain it, ax1 plus by1 plus c, so it's the modulus of that, all over the square root of a squared plus b squared. Now the d is for distance, and we have the modulus of this thing here, so this is just the equation of our line, L1 in this case. It's going to be the equation of our line with the point, the x and the y coordinates of our point substituted in. And then on the bottom here we've got the square root of this number here, the coefficient of the x, to be squared, plus the coefficient of the y to be squared. So let's substitute in our values here. So we've got d is equal to the modulus of, now our particular equation is L1. Let me just write it down here. It's going to be this, this is L1, 3x minus 4y minus 12 equal to 0. So it's going to be, I'll just write it down here. So L1, the equation of L1, so we have L1 here, is 3 times x plus, or no, it's actually minus, I think, minus 4y minus 12 equal to 0. That's the equation of our line. So if we substitute that in here, we get 3 times x. Now there's going to be x1 here, which in this case our x1, y1 is here. So this is x1, this is y1 here. So we put 3 times 10 minus 4 times our y. In this case our y1 is k, so it's going to be minus 4k. It's going to be minus 12, and then all of that is over the square root of a squared. Well, our a is 3, so it's going to be 3 squared, plus our b is minus 4, so it's minus 4, and we've got to square that. So that's our d. So our d then is just going to be the modulus of 30. This is going to be 30 minus 12. 30 minus 12, so that's just going to be 18. And then we've got minus 4k, and that's all over the square root of 3 squared plus 4 squared, so that's going to be 3 3s are 9, minus 4 squared is 16, so it's going to be the square root of 25. So we just end up with d is equal to the modulus of, I'll write it over here, final answer is going to be d is equal to the modulus of 18 minus 4k all over 5. So this is our answer here. We were asked to find in terms of k, so we've done that, it's in terms of k, the distance between the point P and L1. So that's it there. Now, next question. P is the point 10k. We've had that up here. Is on a bisector of the angles between lines L1, this line here, and another line called L2, which is this here. Find the possible values for k. So let me just draw what that might look like first of all. So we have, again, we have, let's say L1 looks something like this. We have our point here, we'll put it down here this time, and it is 10k. So this is 10k, and that's a certain distance from L1. Now we have another line now, which is this line here, L2, and that's, let's say, going to look something like this here. This is L2, and I don't have this drawn too accurately here. Let me just do that a little bit better. Okay, so this is L2 here, and we're told that the point P here, the point P is on a bisector of the angle between these two lines. In other words, there is a if we bisect the angle between these two lines, we'll get a line that looks something like this, where this angle here is equal to this angle here. And we're told that this bisector contains the point P, which is 10K. In other words, the distance from P to L2, this distance here, is also going to be the same as this distance here. These two distances are the same. So that's it, and we've got to find possible values for K here. Okay, so let's have a look at this. Okay, so we know that the distance between the point P and L1 is 18 minus 4K, the modulus of that, over 5. That's this distance here. We've worked that out already. But we know that that's the same as the distance between this point here, this point P, and L2. Now, L2 has equation, L2 by the way has equation 5x plus 12y minus 20 equal to 0. So we know if we find the distance between the point P and this line here, we know it has to be exactly the same as this. So let's write that down. That's going to be the modulus of 5 times x1. Remember, this is still x1, y1 here. So it's going to be 5 times 10 plus 12 times our k here, that's y1, minus 20, and all of that is now over the square root of our new a squared and b squared. This is my a here, so it's going to be 5 squared, plus b is 12, so we're going to square that as well. So this is an equation then that we can solve, because we have an equation here. There's only one unknown in it, k, and that's what we were actually asked to find. So let's look at solving this. Again, I'll just move this out of the way here. Okay, so let's see, what can we do here? Well, let's just tidy this up a little bit first. We have the modulus of 18 minus 4k up here. We have 5 down here, so that's okay. Over here we have 50, 5 times 50, minus 20, so that's just 30 here, plus 12k. Now on the bottom here we have, let me just do it over here separately, within the square root symbol here we've got 5 5s, 25, and then we've got 12 squared, which is 144. Add those two, you get 44, 54, 64, 169. Now we've got to get the square root of 169. The square root of 169 is just 13. So I know I can put 13 here. Now again, we've got a fraction equal to a fraction here, so we can cross multiply, or multiply across by 5 times 13. So we end up with 13 times the modulus of 18 minus 4k is equal to 5 times the modulus of 30 plus 12k. Okay, so now what we can do here, we have a modulus on the left hand side, a modulus on the right hand side. So what we can write down here is 13 times 18 minus 4k can be equal to plus or minus this 5 times 30 plus 12k. So this is one way of doing this. You could square both sides, but it gets kind of, the numbers get very big. This is actually an easier way of doing it. So this comes from the fact that if you take a simple example, the modulus of x is equal to 3, for example, well, the modulus just gets the positive value of this x. So the positive value of what numbers will give you 3? Well, that means x could be 3. In other words, the modulus of 3, the positive value of 3 is just 3, so that works. Or x could be minus 3. So if I put a minus 3 in here instead of x, the modulus of that, the positive value of minus 3, is also 3, so that works. So this works here because this here could be plus or minus, this here could be plus or minus, so you can just put in 1 plus or minus here. So in other words, 13 times 18 minus 4k could be equal to plus or minus this here. Okay, so let's just work these out. We've got two equations here that we need to work out. So let's just look at working both those out. Okay, so let's take the first one. We've got 13 times 18, so that's 234. So I'm just going to multiply these out. 234 minus 4 times 13, which is 52. 52k can be equal to plus 5 times 30, so that's going to be 150. And then I'm just taking the plus version first. So 5 times 12 then is 60, and it's plus, so that's going to be 60k. So if I solve this, then what do I end up with? I get 84. If I just bring the numbers over to one side, I get 84. Bring the k's over to the other side, that'll give me 8k. So if I solve that, I get 3/4 on this side, and I get k here. Divide across by 8. So this is one value for one version of or one solution for k. Let's look at the other one here now again. So I've got 234 again, if I multiply this out, minus 52k. Now I'm going to take the minus version of this, so it's minus 5 times 30, so that's going to give me minus 150, and then minus 60k here as well. Okay, so if I bring the k's over to the left hand side, I end up with again 8k, and bring the numbers over to this side here, I end up with minus 384. Divide across by 8, I get k is equal to minus 48. So these are my two solutions for k, and that's really it for this part. So let's have a look at part 2 then of this one here. Here we're told that k is greater than 0. K is positive. So in this part of the question, so we've got two versions of k here. We've got k is equal to 3/4 and k is equal to minus 48. So in this particular question, we're going to take this one here. So k is equal to 3/4. Find the distance from P to L1. Well, we have a formula for that. We know that D is equal to 18 minus 4k, the modulus of it, divided by 5. We worked this out earlier on. So all we've got to do is work this out now. So we know that k is 3/4. So we've got the modulus of 18 minus 4 times 3/4, all divided by 5. So let's work this out. We've got the modulus of 18 minus 4 times 3/4. So that's going to be 18 minus 3 over 5. That's just going to be equal to the modulus of 18 minus 3 is just 15 divided by 5. Well, the modulus of 15, the positive value for 15 is just 15, so it's 15 divided by 5, which is just 3. Okay, so that's it for question 3.